And now in this lecture we find out the area of a circle using two different methods. In the drawing we have a circle and we also have a square ABCD. You know that this is 97 AP, that is equal to 1 unit in its length. This is 97 QC, that is equal to 3 units in its length. Again, this is 97 AP, that is equal to 1 unit in its length. This is 97 QC, that is equal to 3 units in its length. Again, our mission is to find out the area of this circle. So we start with the first method. First of all, we know that ABCD is a square, and therefore all those four angles are right angles. So this is a right angle, this is a right angle, this is also a right angle, and finally this is a right angle. In the next step, we will define the center of this circle. This point is point O, and we will define the point of tendency of tangent A and B. With this circle, this point is point S. In the next step, we will join points O and S together by a straight line. OS is the radius of the circle because it starts from point O, that is the center of the circle, and ends at point S, that is the point of the circle itself. So this is exactly the definition of a radius. Therefore OS is the radius of this circle. We define the radius of this circle as x, therefore OS equals to x. So here we can implement rule 1. We can click on rule 1. According to rule 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So in the drawing we have a circle, and we have also tangent AB. This is tangent AB, that is tangent to this circle with point M. In addition, we have the radius OM, that is equal to R. The radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to this rule, rule 1. So we can actually implement rule 1 in our drawing. Why? Because in our drawing, we have the radius OS that is equal to x. The radius OS is drawn to point S, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and Q together by a straight line. OQ is of course the radius of this circle, that is equal to x according to the definition. Again, we can implement here rule 1. Why? Because we have the radius OQ is equal to x. The radius of Q is drawn to point Q, that is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. So inside quadrilateral OSBQ, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this 4 preceding angle, in total it must be equal to 360 degrees. according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this four facing angle must be equal to 90 degrees in its size. So inside quadrilateral OSBQ we have four right angles. And according to rule 5, any quadrilateral that has four right angles must be a rectangle if not a square. So we relate to quadrilateral OSBQ as a rectangle because it has four right angles. But we also know know that the opposite sides of a rectangle are equal to each other. So an rectangle OSBQ, side OS must be equal to the opposite side BQ. But OS is x, therefore BQ must be also equal to x units in its length. Likewise, according to the same rule, in the same rectangle OSBQ, side OQ must be equal to the opposite side SB. But OQ is x, therefore SB must be also equal to x units in its length. So we found out that quadrilateral SOQB is not a rectangle but a square, while because of the fact that all of its sides are equal to each other. Each side of this square equals to x. We know that all the sides of square ABCD are equal to each other. That is to say, side AB equals to side BC equals to side CD equals to side DA. And especially side AB equals to side BC. So I write it down. In square ABCD, side AB equals to side CB. Side AB equals to AS plus SB. Again, AB equals to AS plus SB. And it is equals to side CB. Side CB or side BC equals to BQ plus QC. Again, BC equals to BQ plus QC. CB equals to BQ plus QC. So in total, according to equation 1, we have found out that AS plus SB equals to BQ plus QC. AS is the missing side, so we leave it as it is, plus SB. SB equals to X. And it is equals to side BQ. BQ also equals to X. Plus QC. QC equals to 3 units in its length according to what is given as the question. So in total, according to equation 1, we actually found out that AS plus X equals to X plus 3. Here we subtract X from this equation and equation 1, so X will get cancelled. And we left only with AS that is equal to 3 units in its length. So actually found out that the length of the missing line 70 AS is 3 units. This is line 70 AS that is equal to 3 units in its length. In the next step, we will do a construction, that is to say from this point P, we will do perpendicular on OS. Again, from point P, we will do perpendicular on OS, that is the radius of the circle. So actually, this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. When you find the touching point of the perpendicular from point P and the radius OS, this point is point X, it's point N. So by doing this construction, you can deduce the small quadrilateral AP and S. Inside the small quadrilateral AP and S, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this 4 facing angle, in total they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this 4 facing angle must be equal to 90 degrees in its size. So So inside the small quadrilateral A, P, and S, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be this right angle plus a square. So we relate to this small quadrilateral A, P, and S as a rectangle because it has 4 right angles. So write it down. This is quadrilateral A, P, and S. That is a rectangle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So an rectangle AP and S, side AP equals to the opposite side NS. But AP is 1, therefore NS must be also equal to 1 unit in its length. Likewise, according to the same rule, in the same rectangle AP and S, side AS must be equal to the opposite side NP. But AS is 3, therefore NP must be also equal to 3 units in its length. What is the length of the missing line segment NO? From the drawing, it is very easy to see that NO in total equals to SO minus SN. Again, SO minus SN equals to NO. So write it down. NO equals to SO minus SN. So NO in total equals to SO. SO is the radius of this circle, that is X, minus SN. SN is 1. So in total, NO equals to X minus 1 units in its length. This is line segment NO, that is equal to X minus 1 units in its length. In the next step, we will join points P and O together by straight line. PO is of course the radius of this circle, that is equal to X. So in the next step, we will implement the Pythagoras theorem on this right-hand triangle, triangle PON. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So I copy this right triangle PNO in a new page and we will implement the Pythagoras theorem on this right triangle, triangle PNO. Here by PT is the abbreviation for Pythagoras theorem. So here this is the right triangle PNO that I covered from the original drawing. According to the Pythagoras theorem, in this right triangle PNO, PO square, that is the square of the hypotenuse, equals to PN square plus NO square. So I'll write it down. PO square equals to PN square plus NO square. The hypotenuse PO is X, therefore PO square is X square. and it is equals to Pn squared. Pn is 3, therefore Pn squared is 3 squared, that is 9, and plus NO squared. NO is x minus 1, therefore NO squared is x minus 1 squared. So in total, according to the Pythagoras theorem, we shall find out that x squared equals to 9 plus x minus 1 squared. So x squared equals to 9 plus x minus 1 squared. X minus 1 squared equals to x squared plus 1 squared, that is 1, minus 2 times x times 1, that is minus 2x. So here we have x squared on both sides of the equation, so x squared will get cancelled. After we cancel x squared, in this side of the equation we left with nothing, that is to say 0. On the other side of the equation we left with 9 plus 1, that is 10, minus 2x. So in total, we found out that 0 equals to 10 minus 2x. Here we get 2x to this equation, and we get that 2x equals to 10. Here we divide this equation by 2, and we get that x equals to 10 over 2, that is 5. So x is the length of the hypotenuse, PO, it is equals to 5, but x also is the radius of the circle, so the radius of the circle equals to 5 units. Our mission is to find out the area of this circle. Actually, the area of any circle is equal to pi times the radius of the circle squared. Okay, again, the area of any circle equals to pi times the radius of the circle squared. And therefore the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is 5, therefore the radius squared is 5 squared. 5 squared is 25, and therefore in total this expression equals to 25 pi. 25 pi is 78.54 square units. So we found out that the area that we are looking for in this question, that is the area of this circle, it is equal to either 25 pi square units, so in terms of numbers, the area of this circle equals to 78.54 square units. So we finished with the first method. In the next step, I will present to you how to find out the area of this circle according to the second method. First of all, ABCD is a square, therefore all of its 4 angles are right angles. This is a right angle. This is also a right angle. This is a right angle. And finally, this is also a right angle. In the next step, we define the center of this circle. This point is point O. In addition, we also define the point of tendency of tangent AB with this circle. This point is point S. In the next step, we will focus on this common extreme point B. From this common extreme point B, we have two tangents to this circle, tangent BS and tangent BQ. And according to rule 2, they are equal to each other. That is to say BS equals to BQ. So I repeat quickly rule 2. According to rule 2, the lengths of two tangents from a common extreme point to a circle are equal. So in the drawing, we have a circle. This is the common extreme point P. On this common extreme point P, we have two tangents to this circle, tangent PA and tangent PB. And according to this rule 2, they are equal to each other. That is to say, PA equals to PB. As I already mentioned, we can implement rule 2 in our drawing. Well, because in our drawing, we have the common extreme point B. From the common extreme point B, we have two tangents to this circle, tangent BS and tangent BQ. And according to rule 2, they are equal to each other. That is to say, BS equals to BQ according to rule 2. So I write it down. BS equals to BQ according to rule 2. So we define the length of this tangent BS is x, then the length of this tangent BQ must also equal to x, because they are equal to each other. In the next step, we will extend this line segment AD by straight line until it touches the circle. Repeat again, we'll extend line segment AD. AD is also one side of square ABCD, so we'll extend the side AD of the square until it touches the circle at this point. And we will define the touching point of the extended line segment AD with this circle. This point is point M. In the next step, we will focus on this common point, point A. From this common point A, we have tangent AS, and from the same common point A, if we draw this straight line, it will cut the circle at 2 points, point P and point M. So, from the same common point A, we have here chord PM, and also have tangent AS that is tangent to the circle at point S. And therefore we can implement here rule 10. So, repeat quickly rule 10. According to rule 10 is true in any circle. So, in any circle, if AB is any chord in the circle, here AB is the chord inside the circle, and PT is a tangent to the circle. This is tangent PT, this is tangent to the circle, point T. So in this moment, the following equation is true. That PT squared equals to PA times PB. Again, PT squared equals to PA times PB. So we can actually implement rule 10 in our drawing. Why? Because in our drawing, on this common point A, we have tangent AS. On the same common point A, we have this chord called PM. If we draw a straight line from point A, it will cut the circle 2 points, P and M. In this way, candidate called PM. So all the requirements of rule 10 are satisfied, and therefore we can implement a rule 10. According to rule 10, the following equation will be true. That AS squared equals to AP times AM. Again, AS squared equals to AP times AM. So I write it down. So if we focus on the common point A, according to rule 10, the following equation will be true. That AS squared equals to AP times AM. Repeating again. The common point A, according to rule 10, the following equation is true. That AS squared equals to AP times AM. So actually we have to find out the length of tangent AS. Okay? What is the length of tangent AS? We know that all the sides of square ABCD are equal to each other. That is, to side AB equals to side BC equals to side CD equals to side DA. And especially side AB equals to side BC. in square ABCD, side AB equals to side BC. Actually, in the first method, we have already found out that AS equals to 3, but we'll find out the graph of 97 AS again. So in square ABCD, side AB equals to side BC. AB in total equals to AS plus SB, and it is equals to side BC. BC in total equals to BQ plus QC. So repeat again. Actually, in square ABCD, side AB equals to side BC. AB equals to AS plus SB, BC equals to BQ plus QC. So in total, according to equation 1, we have found out that AS plus SB equals to BQ plus QC. AS is the missing side, so we leave it as it is. Plus SB, SB is X. And this equals to BQ, BQ is also X. Plus QC, QC equals to 3 units in itself, according to what is given as the question. So in total, according to equation 1, we have found out that AS plus X equals to X plus 3. Here we subtract X from this equation 1, so X will get cancelled, and we're left only with AS that is equal to 3 units in its length. So the length of 97 AS is 3 units. Write it down. So we return back to rule 10. I'll repeat again on what we have already done. If you focus on this coming point A, on the coming point A, we have tangent AS, and also we have here chord PM. So all the requirements of rule 10 are satisfied, and therefore we can implement a rule 10. According to rule 10, the following equation is true, that AS square equals to AP times AM. Again, AS square equals to AP times AM. Again, if we focus on the current point A, according to rule 10, the following equation is true, that AS square equals to AP times AM. AS is 3, therefore AS squared is 9, and it is equals to AP is 1 times AM. AM in total equals to AP plus PM. Again, AM in total equals to AP plus PM. So according to rule 10, 9 equals to 1 times AP plus PM. 1 times any expression equals to the same expression, so 1 will not change the values of the expression, so you can ignore 1, and you can also open the brackets, and we get that 1 times AP equals to AP plus 1 times PM is PM. So you can ignore 1, or you can either ignore 1 or you can open the brackets and we get the same expression, AP plus PM. So this equation equals to 9, that is equal to AP plus PM. Nine equals to AP plus PM. 9 equals to AP. AP is 1 plus PM. Here you subtract 1 from the equation and you get that PM equals to 9 minus 1 is 8. So the length of this chord PM is equal to 8 units. Chord PM equals to 8 units in its length. In the next step, we will do a construction, that is to say, from this point O, that is the center of the circle, we will draw perpendicular or chord PM. Again, from point O, we will draw perpendicular or chord PM. So calculate this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and chord PM. This point is point 10. In conclusion, actually draw a straight line from point O, that is the center of this circle, on chord PM. And therefore, we can implement here rule 11. Whenever you draw a perpendicular from the center of the circle towards any chord, you can implement rule 11. So, I'll repeat quickly on rule 11. According to rule 11, the perpendicular to a chord drawn from the center of the circle bisects the chord. So, in the moment we have a circle, inside this circle we have this chord called AB. Point O is the center of this circle. From point O, that is the center of the circle, we do perpendicular OM on chord AB. Again, from point O, we do perpendicular OM on chord AB. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. And according to this rule 11, the perpendicular OM that is drawn from point O, that is the center of the circle, will bisect chord AB. Perpendicular OM bisects chord AB. If OM bisects chord AB, it means that perpendicular OM divides chord AB into two halves. Each half equals to AB over 2, of course. Each half equals to AB over 2. The first half is AM, that is equals to AB over 2. The second half is MB, that is also equals to AB over 2. So according to rule 11, AM equals to MB equals to AB over 2. Okay, so whenever you draw a perpendicular from the center of the circle towards any chord, it will bisect the chord. Here, chord OM, perpendicular OM bisects chord AB. It divides chord AB into two halves. The first half is AM, and it is, of course, equals to the second half, that is MB, and each half equals to AB over 2. So AM equals to MB equals to AB over 2. So we can definitely implement rule 11 in our drawing. Why? Because in our drawing, from the center of this circle, that is to say from this point O, we do perpendicular ON on chord PM. So all the requirements of rule 11 are satisfied, and therefore we can implement rule 11. According to rule 11, perpendicular ON that is drawn from the center of this circle, that is to say from point O, bisects chord PM. That is to say, it divides chord PM into two halves. Each half, of course, equals to PM over 2. So the first half is NM, that is equal to PM over 2, and the second half is NP, that is also equals to PM over 2. So I write it down. According to rule 11, perpendicular ON bisects chord PM. The first half is NM, and it is of course equals to the second half, that is NP, and each half equals to PM over 2. So according to rule 11, we should found out that Nm equals to Np equals to Pm over 2. Pm is 8, therefore Pm over 2 is 8 over 2, that is 4. From this long equation, we derive that Np equals to 4. Np equals to 4 units in its name. So actually, this is 9 segment A and B that is equal to 4 units in its length. In the next step, we will join points O and S together by side line. Point S is the point of tendency of tangent AB with this circle. Line segment OS is of course the radius of this circle. So I write it down. This is line segment OS, that is the radius of this circle. Because of the fact that the radius OS is drawn to point S, that is the point of tendency of tangent AB with this circle, whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So inside quadrilateral ANOS, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this fourth missing angle must be equal to 90 degrees in its size. So inside quadrilateral ANOS, we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be a rectangle, not a square. So we relate to this quadrilateral ANOS as a rectangle because it has 4 right angles. So I write it down. This is quadrilateral ANOS, that is a rectangle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ANOS, side AN must be equal to the opposite side OS. But AN in total equals to 1 plus 4, that is 5, therefore OS must be also equal to 5 units in its length. But OS is the radius of the circle, and therefore the radius of this circle equals to 5 units in its length. Actually found out that the radius of this circle is equal to 5 units in its length. Our mission is to find out the area of this circle. Actually, the area of any circle is equal to pi times the radius of the circle squared. And therefore, the area of our circle must be equal to pi times the radius of our circle squared. So it is pi times the radius of our circle, that is 5 squared. So in total, the area of our circle is pi times 5 squared. Pi times 5 squared. 5 squared is 25, so in total this expression equals to 25 pi, that is actually equals to 78.54 square units. So actually, in both methods, we found out that the area of this circle it is equal to either 25 pi square units, or in terms of numbers, the area of this circle equals to 78.54 square units. So in the next step, I will summarize the lecture. We'll start with the first method, of course. In this lecture, our mission is to find out the area of this circle. Actually, we found the area of this circle using two different methods. So in the domain we have a circle, and this is square ABCD. Square ABCD cuts the circle at point P, and side BC is tended to this circle at point Q. Side AB of square ABCD is tended to this circle at this point S. Again, our mission is to find out the area of this circle. So we start with the first method. The first method, you know that all the four angles inside square ABCD are right angles. So all those four angles are right angles. And the next step, we define the center of this circle. This point is point O. We define the point of tendency of tangent AB with this circle. This point is point S. In the next step, we join points O and S together by a straight line. OS is the radius of this circle. We define the radius of this circle as x. Therefore, OS equals to x. So here we can implement rule 1 because we have the radius OS that is equal to x. The radius OS is 1 to point S, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is 1 to the point of tendency, then tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and Q together by straight line. OQ is of course the radius of the circle, that is equal to x. The radius of Q is 1 to point Q, that is the point of tendency of tangent BC with this circle. And whenever your radius that is 1 to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. So inside quadrilateral SOQB, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this 450 degrees, in total the mass is equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this 450 angle must be equal to 90 degrees in size. So inside quadrilateral SOBQ we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be this rectangle and not a square. So we relate to quadrilateral SOQB is a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So an rectangle SOQB, side SO must be equal to the opposite side QB. But SO is x, therefore QB. SO is x, therefore QB must be also equal to x units in its length. Likewise, according to the same rule, in the same rectangle SOQB, side OQ must be equal to the opposite side SB. But QO is x, therefore SB must be also equal to x units in its length. So actually found out that quadrilateral SOQB is not a rectangle but a sphere, because of the fact that all of its sides are equal to each other. Each side of this sphere is equal to x units in its length. We know that all the sides of this square ABCD are equal to each other. That is to say, side AB equals to side BC. So here in square ABCD, side AB equals to side CB. AB is AS plus SB. AB is AS plus SB. BC is BQ plus QC. BC is BQ plus QC. So in total, according to equation 1, AS plus SB equals to BQ plus QC. AS is the missing side, so many vertices, plus SB. SB is X. And it is equals to BQ, BQ is also x, plus QC, QC is 3. So in total, according to equation 1, we actually found out that AS plus x equals to x plus 3. We have substituted x from this equation, so x will get cancelled, and we left only with AS that is equal to 3 units in its length. So actually found out that the length of this missing 97 AS is 3 units. Okay, so in the next step, we did a construction. That is to say, from this point P, we draw perpendicular on the radius SO. Again, from point P, we draw perpendicular on the radius SO. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P and SO. This point is point N. By doing this construction, we can deduct quadrilateral AP and S. Inside quadrilateral AP and S, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this 450 angle, in total it must be equal to 360 degrees according to the rule that states then the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this fourth angle must be equal to 90 degrees in size. So inside quadrilateral A, P, and S, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be this right angle if not a square. So we relate to quadrilateral A, P, and S as a right angle because it has 4 right angles. But we also know that the opposite sides of a right angle are equal to each other. So in right angle AP and S, side AB must be equal to the opposite side NS. But AP is 1, therefore NS must be also equal to 1 unit in its length. Likewise, according to the same rule with the same right angle AP and S, side AS must be equal to the opposite side NP. But AS is 3, therefore NP must be also equal to 3 units in its length. What is the length of the missing line segment NO? From the drawing, it is very easy to see that NO in total equals to SO minus SN. Again, NO equals to SO minus SN. So NO equals to SO, that is X, minus SN, that is 1. So in total, NO equals to X minus 1 units in its length. In the next step, we join for each P and O together by straight line. PO is of course the radius of this circle, that is equal to X. So in the next step, we implemented the Pythagoras theorem with this right triangle P and O. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So this is the right triangle P and O that I call it from the original drawing. According to the Pythagoras theorem, in this right triangle P and O, PO square, that is the square of the hypotenuse, equals to Pn square plus NO square. PO is X, therefore PO square is X square. And it is equals to Pn square. Pn is 3, therefore Pn square is 3 squared, that is 9, plus NO square. NO is 3, NO is X minus 1, therefore NO square is X minus 1 squared. So in total, according to the Pythagoras theorem, X squared equals to 9 plus X minus 1 squared. So X squared equals to 9 plus X minus 1 squared. X minus 1 squared equals to X squared plus 1 squared, that is 1, minus 2 times X times 1. This is minus 2x. So here we have x squared on both sides of the equation, so x squared will get cancelled. After we cancel x squared, this side of the equation will be left with nothing, that is to say 0. On the other side of the equation, we left with 9 plus 1, that is 10, minus 2x. So in total, we should find out that 0 equals to 10 minus 2x. Here we added 2x to this equation, and finally found out that 2x equals to 10. Here we divided this equation by 2, and finally found out that x equals to 10 over 2, that is 5. So actually the length of the hypotenuse PO is 5, and x is also the radius of this circle, so the radius of this circle equals to 5 units in its length. Our mission is to find out the area of this circle. Actually the area of any circle equals to pi times the radius of the circle squared. Therefore the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is 5, and therefore the radius squared is 5 squared. So in total, the area of our circle must be equal to pi times 5 squared. 5 squared is 25, so in total this expression equals to 25 pi. Or in terms of numbers, it is 78.54 square units. So if we found out the area of this circle, that is the area that we are looking for in this question, it is equals to either 25 pi square units, so in terms of numbers, the area of the circle equals to 78.54 square units. We finish with the first method. In the next step I presented to you, I have to find out the area of the circle according to the second method. In the second method, actually, we know that all the angles inside square ABCD are right angles. So those 4 angles are right angles. We define the center of this circle, this point is point O. We define the point of tendency of tangent AB with this circle, this point is point S. Then we focus on this common standpoint, point B. From this common standpoint, point B, we have 2 tangents to this circle, tangent BS and tangent BQ. And according to rule 2, they are equal to each other. That is to say, BS equals to BQ. Again, BS equals to BQ according to rule 2. So if we define the length of tangent BS as X, then BQ also must be also equal to X because they are equal to each other according to rule 2. We know that all the sides of square ABCD equals to each other. That is to say, side AB equals to side BC. So repeat again, in square ABCD, side AB equals to side BC. AB equals to AS plus SB. Again, AB equals to AS plus SB. and it is equals to BC. BC equals to BQ plus QC. And BC equals to BQ plus QC. So in total, according to equation 1, we have found out that AS plus SV equals to BQ plus QC. AS is the missing side, so we leave it as it is. So it is AS plus SB. SB is X, and it is equals to BQ. BQ is also X plus QC, that is 3. So in total, according to equation 1, we have found out that AS plus X equals to X plus 3. Here we substituted X from this equation 1. So X will get cancelled, and we have to only with AS, that is equals to 3 units in its length. So we have found out that this missing 97 AS is equal to 3 units in its length. In the next step, we extended side AD of this square ABCD, or line segment AD. We extended it by straight line until it touches the circle, and we define this touching point with the extended line segment AD with the circle. This point is point M. So from the current standpoint point A, we obtain that AS, and from the same current standpoint point A, if we draw this straight line, we create the straight line will cut the circle at 2 points P and M. So from the same current standpoint point A, we have here called PM. Repeat again, from the external point current standpoint point A, we have tangent AS, and also we have here called PM. So all the requirements of rule 10 are satisfied, and therefore we can implement in rule 10. According to rule 10, we get that the following equation is true, that AS square equals to AP times AM. Again, AS square equals to AP times AM. Once again, if we focus on the current standpoint point A, according to rule 10, AS square equals to AP times AM. AS is 3, therefore AS squared is 3 squared, that is 9, and it is equals to AP. AP is 1 times AM. AM in total equals to AP plus PM. Again, AM equals to AP plus PM. AM equals to AP plus PM. So in total, I should found out that 9 equals to 1 times AP plus PM. Here, you can either open the brackets. 1 times AP is AP, 1 times PM is PM, or you can also ignore the 1, because anything that is multiplied by 1 will not change the value of it, will not change its value. So anyway, we get here that 9 equals to AP plus PM. 9 equals to AP plus PM. 9 equals to AP, AP is 1, so 9 equals to 1 plus PM. We have subtracted 1 from this equation. So PM equals to 9 minus 1, that is 8. So if we found out that the length of this chord PM is equal to 8 units in its length. In the next step, we did the construction. That is to say, from this point O, that is the center of this circle, we do perpendicular on chord PM. Again, from point O, we do perpendicular on chord PM. So this angle equals to 90 degrees, and this angle also equals to 90 degrees. Is equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and chord PM. This point is point N. So in conclusion, actually, from the center of the circle, that is to say from this point O, we do perpendicular on chord PM. And therefore, all the requirements of rule 11 are satisfied, and therefore we can implement in rule 11. According to rule 11, the perpendicular ON that is drawn from point O, that is the center of the circle, bisect chord PM. Again, perpendicular ON that is drawn from point O, that is the center of the circle, bisect chord PM. That is to say, it divides chord PM into 2 halves. Each half also equals to PM over 2. So the first half is PN, and it of course equals to the second half, that is NM, and each half equals to PM over 2. So according to rule 11, perpendicular ON bisects chord PM. The first half is NM, and it is equal to the second half, that is NP. Each half equals to PM over 2. PM is 8, so PM over 2 is 8 over 2, that is 4. 8 over 2 is 4. So actually, for this equation, we derive that NP equals to 4 units. NP equals to 4. So actually, this is line segment NP that is equals to 4 units in its length. In the next step, we join points O and S together by straight line. OS is of course the radius of the circle. So here, note down that OS is the radius of the circle. So here, the radius OS is drawn to point S. That is the point of tendency of tangent AB with this circle. Whenever your radius is drawn to the point of tendency, then tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. By doing this construction, we get the quadrilateral ANOS. Inside this quadrilateral ANOS, we have 1, 2, 3 angles. This angle equals to 90 degrees according to our construction. This angle equals to 90 degrees because of the fact that ABCD is a square. And this angle equals to 90 degrees according to rule 1. So inside quadrilateral ANOS, we have 3 angles. The sum of 3 angles is 270 degrees. So 270 degrees plus the size of this 4th missing angle, in total it must be equal to 360 degrees. According to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees, and therefore this 4th missing angle must be equal to 90 degrees in its size. So inside quadrilateral ANOS, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be at its right angle equal to a square. So we relate to quadrilateral ANOS as a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ANOS, side AN must be equal to the opposite side OS. But AN in total equals to 1 plus 4, that is 5. Therefore OS must be also equal to 5 units in its length. OS must be also equal to 5 units in its length. But OS is the radius of the circle. Therefore the radius of the circle equals to 5 units in its length. Our mission is to find out the area of the circle. Actually, the area of any circle equals to pi times the radius of the circle squared. Therefore, the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is 5, and the radius squared is 5 squared. So in total, the area of our circle must be equal to pi times 5 squared. 5 squared is 25, so in total this expression equals to either 25 pi or 78.54. So in total, in both methods, we actually found out that the area of the circle, that is the area that we are looking for in this question, it is equal to either 25 pi square units, or in terms of numbers, it is equal to 78.54 square units. Okay, thank you very much.